Hello everyone and welcome to this, my video on transformations of graphs of functions. And you're probably going to turn around and go, isn't that what you've been doing in the last 97 videos? Well, you could argue that. If you're new to my channel, my name's Darren from Maths Guru, and it's lovely to see you. Thank you very much for stopping by. Hopefully this video is going to be useful. It's part of the Mathematical Methods Units 1 and 2 course over here in Australia. But to be perfectly honest with you, it is equally valid for A-levels and every course throughout this country, because it's about moving graphs around, and it is fabulous if I do say so myself. It's actually the last video in the series, so if you haven't watched the rest, head over to mathsguru.com. A little corner of the internet is free to sign up with everything I'm about to write down, like downloadable lesson notes, all the videos in order, mapped against Cambridge, thank you Cambridge, and VCAR questions or VCAA questions, and so much more. Now, I normally start with learning objectives. This one just says to be able to find equations of images when given the transformations using substitution algebra. And I have to say, I love substitution algebra. But there are lots and lots of different ways of doing this. So let's continue. I'll recap, as I say, this is the final lesson in the series, and if you haven't watched the others, there's lots. This is really the foundation to the work we are going to do in Mathematical Methods Units 3 and 4, for those of you who are considering taking it. But, you know, in many cases, it's just a carbon copy. We just go a little bit deeper. But realistically speaking, I suppose this video is about all the different ways we can trick you. Now, one of those is to give you a very strange language. And again, if we look at it here, this is just a way of saying, well, if we have a reflection in the x-axis or y-axis, or dilations or translations, what is the rule to be able to go from one to the other? And here we got the original and the image. So when we reflect in the x-axis, what we're saying is all of our y coordinates negate. What was -1 becomes 1. What was, 2 becomes -2. Likewise, when we reflect in the y-axis, what happens? Our x values negate. Yes, what the y values stay the same, the x values negate. Dilation of factor A from the y-axis, we find that actually we can replace x with ax. This is all very exciting, and so we go on. All right, so these are this is also basically shortcuts if we've been given the idea of a function. If you don't understand that, that's fine. Don't worry about it. I've got examples coming up through this video. Now, before I start example 1, can you do me a massive favor and subscribe to my YouTube channel? Turn off notifications if you never want to hear from me, which sort of defeats the object. But anyway, why I'm asking you to subscribe? Because so very few people watch maths videos. Like, seriously, if I get 3 subscribers at the end of the day, I go nuts. Yesterday I got 16. Honestly, it nearly fell over. Nearly had a heart attack. That would have been the end of this series. It just tells me that you're watching. Basically, I currently am sitting in a room on my own, talking to myself really quietly so I don't wake up my 4-year-old daughter, just creating content for you guys. So subscribing really does mean the world to me. And that's the needy stuff over. Right, example 1. And the best thing to do is just go straight into examples. Why? Because we've already done the theory in previous videos. A transformation is defined by the rule xy maps to 1/3 x and 2y. Find the equation of the image of the graph. Now, we get so used to being tied into particular examples, and then suddenly in an exam up comes this question here. And I know that I did this recently with my own group, and many of the boys were like, no idea how to do this one, and so sort of stalled, because it didn't look like the type of question before. Now, without being unkind, there are those of you out there who understand the maths, and those of you who effectively regurgitate. And regurgitation is fine. It will get you, I don't know, 20, 25 maybe, but it's the understanders who will go further. Right, let me see. So what we're going to do now is use substitution algebra, 1/3 x, comma, 2y. And if you remember from my previous videos, what I now do is write that as x dashed and y dashed. And that means, therefore, that 1/3 x is equal to x dashed and 2y is equal to y dashed. Now, why am I doing this? He says, no pun intended, because I am trying to find a way of replacing the x's and y's in here with x dashed and y dashed, because we are trying to map every ordinary coordinate onto some sort of an image. And again, so many of my videos talk this through. Hopefully by now you're like, oh yeah, this is awesome. Times both sides by 3 gives me that x is equal to 3x dashed, and that y becomes equal to y dashed on 2. Here we go. So what do? And basically the hard work is done, because everywhere I see an x in my equation, I'm going to do that. Every time I see a y, I'm going to do that. Now, in which case I'm not going to put the dashes anymore, because I know I'm going to change from my original to my image. So my image has an equation of y equals x squared. Well, everywhere I see an x, I'm going to put 3x squared. And I've got plus 2x, and I've got a 3x there, and a plus 3. Now, hopefully you're screaming at the screen now going, no, you've made a mistake. Yes, and again, lots of people do this. They forget that you've got to substitute for both the x and the y. Lots of people do this, but then they forget that, well, no, that y should have been replaced with y dashed on 2, which is actually y on 2 for our image. So this is now the equation of my image. This is what would happen if I take this original function here, and I basically transform it by taking all of my x values and a thirding them, and do all of my y values and doubling them. So that realistically that would stretch that way, and it would pull everything in that way. So what I'm going to do now is I'm going to multiply out this side first, or square everything first before I try and get too complicated, one thing at a time. Y on 2 is equal to 9x squared. The number of people out there who think that 3 squared is 6 really terrifies me. Plus 6x plus 3. There we go. Now what I'm going to do is multiply everything by 2, which gives me 18x squared plus 12x and plus 6. And ka-ching, there we go. That is the equation of the image of the graph under that transformation. All right. Again, builds on what we did before. We are trying to say, well, there is my, what do we even call that? There's my transformation. Yep. I'm going to make x dashed and y dashed, do a little bit of algebra here, substitute it into there, and then effectively wobble it down there. God, have you ever heard a maths teacher say wobble it down there? No, me either.